Alright, so let's go over our line structure practice now. These first few problems, we're just trying to determine chemical formulas. And so we need to locate the carbons here. So 1 here, 2, 3, 4, 5, 6. So C6. Hydrogen comes next in our chemical formula, and then oxygen. Is there a correct order to put the elements in a chemical formula? The answer is yes. It's always carbons first, then hydrogens, and then the remaining elements go in alphabetical order. The oxygens should also be straightforward to count up because we can just see each of them on here. And we can see that we have 6 of them. So the most challenging part usually ends up being the hydrogens. And really what we have to do is just go atom by atom and determine how many hydrogens are there. So if we start with the oxygens, we can see we have 1, 2, 3, 4. Now if we start going to the carbons, first of all we can see this carbon here has a double bond to the oxygen, a single bond to the oxygen, and a single bond to another carbon. So there's already 4 bonds there, so we don't need any hydrogens. So I'm just going to put an X through it to note that we've counted it. This carbon here has a double bond and 2 single bonds. Again, already have 4 bonds. Same thing is true for this carbon. This carbon here, though, we can see it has 1 bond to oxygen, 1 bond to carbon, and a second bond to a second carbon. So it has 3 bonds already, but it needs a hydrogen. So there's 1 hydrogen here. This carbon, we can see 2 bonds to other carbons and 1 bond to another oxygen. So we need 1 hydrogen here. And finally, this carbon has a bond to carbon and a bond to oxygen. So it needs 2 more hydrogens to get to 4. And so we have a total of 8 hydrogens in this molecule. And this molecule, if you're wondering, anyone know what this molecule is? This is vitamin C. Alright, our next part, we can see we have carbons here, here, 3, 4, 5, 6, 7, and 8. So C8. And then we go through each carbon. And we actually have a lot that are very similar. In fact, all the ones that I'm going to draw blue arrows to right now, those 5 carbons are only bonded to 1 other carbon. So they each need 3 more hydrogens. So that's 15 hydrogens. This carbon is bonded to 3 other carbons, so it needs 1 more. This carbon here is bonded to 2 carbons, so it needs 2 hydrogens. And finally, this one that I'm putting in green, that carbon is bonded to 4 other carbons, therefore it has no hydrogens, and we have a total of 18 hydrogens. And this molecule you may or may not have recognized is the line structure for isooctane. Now in C and D we also have molecules we may know. We have leucine, which is an amino acid, and in the last one we have acetaminophen, which we may know as the active ingredient in Tylenol. But we do the same things in each one of these. Each of these we're going to have carbon, hydrogen, nitrogen, oxygen. So we can count the carbons. 1, 2, 3, 4, 5, 6. Same thing here. 1, 2, 3, 4, 5, 6, 7, and 8. Nitrogens, we have 1 in each molecule. So we know that we don't put a number there. We'll move the oxygen right up against it. And we also have 1, 2 oxygens here. And here in acetaminophen, we also have 2 oxygens. So it just remains for us to count up the hydrogens. We have 3, 2, 1, 3, 1, and then the 3 that are drawn in. So that's 1 plus 2 is 3, plus 2 is 5. Three, 6, 9, 10, 11, 12, 13. Same thing in part D. We have 3 here. This next carbon has none because we can already see 4 bonds. We have the 1 on the nitrogen, the 1 on oxygen. Then each of these carbons in the ring are all very similar. They have a double bond to another carbon, and they have a single bond to another carbon. So we have 3 bonds, which means there's 1 that's not drawn in. And then the last 2 carbons, here and here, they each have a double bond, a single bond, and then a single bond either to nitrogen or to oxygen, which means they have 4 bonds total, so they have no hydrogens. So now we just need to add up the hydrogens. We have 1 here, 2, 3, 4, 5, 6, 7, 8, 9. All right, our other question on this exercise looks at finding errors. So what's wrong in each of these line structures? So in the first one, what's wrong is this nitrogen. Nitrogen needs 3 bonds. And remember, with any atom that's not carbon, we can't assume atoms are there. So this nitrogen is missing a bond. In number 2, we have this carbon down here that has too many bonds.